Hello students, I'm Dr. Jaya from Marri, Laxman, Reddy Institute of Technology and Management in the Department of Computer Science and Engineering Data Science. So in the last class, we have discussed about the reliability design, and up to CLASS-02, we have done the problem with the reliability and all that. Now we'll continue the rest of the problem with the S3. All right. Actually, we have did the problem, yes, the final yes to, we got the answer so that we can continue the next process. That is 0.72 comma 45 and next 0.864 comma 60 and next 0.8928 comma 75, 0.98208 comma 105. So this is the last CLASS-02 we have calculated, and this is a final CLASS-02. Now we need to calculate the CLASS-03. So CLASS-03 also we have the 3 copies. We got the U3 value is like 3 copies. So that 3 copies now we need to continue. All right. So now CLASS-03 can be calculated from CLASS-02 so that we can obtain S13, S23 and S33. So these are all the 3 copies that we are going to calculate for the next procedure. So again we'll start. So this is J value and this is I value. I value will be the constant, J value will be the changes, and that will be comes under the M1 value, M2 value and M3 value. Alright, so designing the concept, reliability design is a concept where we need to come with the devices as well as the copies, at most copies. We need to find out the maximization. Alright, now for this we need to take 1 less than Mi less than Ui, that is 1 less than M3 less than, what is now U3. So U3 means 3 copies, we got the answer. So now M3 you are going to written as 1, 2, 3. 3 times we need to calculate this M3. Okay. So now we are moving on to what now? S13. S13 can be calculated as, here we need to take the I value equals to 3. This is your I value and this is your J value. J value equals to 1 and M3 value equals to 1. The first point we need to take. Alright. So this all the 3 values that we have taken, and now we are going to calculate. You remember the formula? Pi I Mi equals to 1 minus R3 to the power M3. In the place of 3 we have kept like I. So I value now we are going to take it as what? 3. So 1 minus R3 to the power M3. So we need to substitute all these values in this particular equation as we have discussed in the previous session. So now what is the value of R3? 1 minus. What is the value of R3? 0.5. That is 1. And now 1 minus 0.5 to the power 1. So that is 0.5. So we got the value is what? 0.5. Alright. 0.5 we got the value. Now the 0.5 value we need to calculate with the S13. So with the previous value you need to calculate with this new value. So what is the first value now? 0.5 into 0.72 comma. What is the value? Cost 45. Plus the cost of that is 20. Next 0.5 into, what is the next value? 0.864. What is the next value? 60 plus 20. Next value 0.5 into 0.8928 comma 75 plus 20. Next 0.5 into 0.98208 comma 105 plus 20. These are all the S13 values that we have calculated with the 0.5 with the previous of S2 final value. Now, by taking this, we are going to get 105 plus 20. This is more value. Alright, we can remove directly by seeing this. Why? Because it is the highest. Why? Because we have the capacity is what? 105. Alright, 105 plus 20. So these are all we can calculate now. So you are going to get the value is 0.36. 0.5 into 0.7 to 0.36 plus 45 plus T is 65, comma 0.432, comma 60 plus 20 is 80. Next 0.4464, comma 75 plus this is 90. We have removed this. Alright, 65 we have, 80 we have, and 90 we have. All in the normal procedure. So it is exceeds. We can write our highest value we can write. So this is a concept. Now S2. S23 is calculated. Again here I value equal to 3, J value equal to 2, M3 value equals to 2. This is for the second procedure you are going to calculate it. Again substitute in the formula same. Alright. What you are going to get? 1 minus what is the R3 value? 0.5 whole to the power. Now you need to write here what? 2. Already 1 completed. Now we are moving on to the M3 value, that is 2. So square you are going to get 1 minus 0.25 you need to get, that is 0.75. Alright. So this we got here. Again now we need to calculate with the 0.75 with S2 final value. So now S2 3 equals to. So it's a long bit like procedure calculation part we have. So 0.75 into 0.72. Now 45 you need to take plus 2 into 20 times. Alright, why? Because that is 1 into 20, 2 into 20 and 3 copies means 3 into 20 like that. 2 into 20. And next is 0.75 into 0.864. So please tell me 60 plus 2 into 20 again. Alright. And next is 0.8928 into 0.75. 75 plus 2 into 20. Next again 0.75 into 0.95208. 105 plus 2 into 20. Every time we need to calculate this means every time you need to calculate for the comparisons. Alright. So already this is exceed. You need to remove as a previous. And this is also 75 plus 2 into like 20, 40. This is also exceed and we can remove. Alright. These two, by seeing that only we can remove the part. Alright. Now we are going to get S23 is equals to 0.54 when we calculate that, and you are going to get is what? 85. 45 plus 40. Alright. And next 0.648 comma 100. This is the part. Alright. So this is 85 and this is 100. We got the S2 value. Again, yes. 3 is calculated as. Alright. I equals to 3, J equals to 3, M3 equals to 3. 1 minus R3 to the power of M3. 1 minus 0 to 0.53. What we are going to get? 1 minus 125, that is equals to 0.875. We are going to get the answer as yes 3. Now again this value will be calculated again with the yes 2 part. All right. Now yes 3 is calculated. All that again we need to calculate. 0. This 875 into 0.72. Now tell me, students, 45. 2 into 20. What I told, for 1 copy 1, 2 copy 2. Now 3 is what? 3 copy. Plus 3 into 20. Next 0.875 into 0.864. 60 plus 3 into 20. Again. Now 0.875 into 0.8928. 75 plus 3 into 20. 0.875 into 0.9528 into 105 plus 3 into 20. So, by checking this, this is you're going to be removed. All the 3 parts you're going to remove. So, once again. .875 into 0.864, 60 plus 3 into 20, 875, 75 plus 3 into 20, 875 into 0.98, 105 plus 3 into 20. These 3 will be removed. Why? Because you are going to get the highest value. Okay, children. So, what you are going to get the last answer only for the first one, that is 0.63. You will get comma 105. Exactly. All right. The exact value we have reached, that is what? 105. All right. So, yes 3 can be obtained. Now we need to merge. Yes 3 can be obtained by merging yes 1 3, yes 2 3, yes 3 3. So the overall result that you are going to get, now we need to compare with all. First one is 0.36 comma 65, 0.43 comma 80, 0.4464 comma 95, 0.54 comma 85, 0.648 comma 100, 0.63 comma 105. Altogether we have written. Now here 65 is there, 80 is there, it is okay. Now 85 and 95 is there, it's also okay. But 95 after that 85 is there. So it should not be in the increasing order. So what happens is this is a fail, means you have to remove it. So you need to consider the pair again. So what is the pair you are going to get here? Alright, true, false, 85, 95. So true and true. You are going to be remove that. Alright, so this is failed and you have to remove. What is the new value of yes 3? Now 0.36 comma 65, 0.43 comma 80, 0.54 comma 85, 0.648 comma 100, 0.63 comma 105. This is the new value. Alright, after getting the new value, now you are going to consider 0.648 with 100 and 0.63 with 105. So, what is the value that you are going to be exceed? 0.63. Alright, so 0.648. So, this is okay, this is okay, this is okay, this is okay. Now, the comparisons with which maximization that we need to consider here. Alright, the pair that you need to take is what? Maximization profit. Here, you are going to be get the low with more cost. Here, less 105 with more, and 0.63 we are going to get the maximization. So we need to remove the pair is what? 0.63. Yes 3 value. yes, 3 value, that we got all that. Now with you're going to get the maximization with 648. So you need to consider this value. All right. Next is what, ma? Yes, 3. Yes, 3, you need to take it as 0.36 comma 65, 0.432 comma 80, 0.54 comma 85, 0.648 comma 100. Why? Because with less cost you are going to get the maximization is with high. So that's why we need to remove the pair of 105. So this reliability design is the final output that we are going to get, and we need to obtain yes 3. This is came from what, ma? Yes 2. Yes 2 is came from what, ma? Yes 1 1. All right. So like that we need to consider all this pair. So now yes 1 again to what, ma? Yes not. So how many copies we have did all that required combination? 1 copy for device D1 and 2 copies of device D2 and 2 copies again. 2 copies of device D3. So M1 equals to 1 and M2 equals to 2 and M3 equals to 2. So this is your final answer. How you want to get like S3 from S2, S2 to S1, S1 to S0. All right, where all the copies that are going to be present. So what is the best design you are going to take here? The best design is 0.648 comma 100. Alright, this reliability with the cost is what? 100, and this where it is going to present this yes 2 3. It is present in what? Yes 2 3. Alright, where I value equals to 2, I value equals to 3, sorry, and J value equals to 2 and M3 value equals to 2. So that's why that copies that we have taken is what? 2. Alright, yes 3 value. And 0.6800 can be obtained from this value. Yes. Yes 2 2. That is 0.864 comma 60, which is present in yes 2 2. So where we are going to take I value equals to 2 and J value equals to 2 and M2 value equals to 2. This again it came from yes to 2. And now, so this again 864 comma 60, which is obtained from 0.9 comma 30, which is present in yes 1 1. So I value equals to 1, J value equals to 1 and M1 value equals to 1. So that's why we have taken the copies. So it came from yes 1 1, yes 2 2 and yes 3 2. So that's why M1 equals to 1, M2 equals to 2 and M3 equals to 2 copies. So this is our final answer of devices which we have solved for reliability design. All right, I hope it is clear. Thank you.